This is the future train of Singapore. What you will see next is an invention dedicated to these trains. So here we go. Good morning. There is a revolution happening all around us. It is one that will help us to conquer one of the greatest challenges in the railway industry. We call this to prevent problems before they happen using sensor fusion. Today, I'll be talking about the introduction, our invention, case studies, benefits, development process, and the conclusion. Firstly, let us start off with the introduction. Now, let's go for a ride. This car crash accounted for 16 G-forces, which is 16 times of the force of gravity. For the train vibration, it's more than that. Like the metallic wheels rubbing on the metallic track, it can generate up to 30 G-forces, which is double that of the car crash. That's the reason why we need the train health monitoring. This guy here is doing the visual inspection, looks for the loose component. This one, the ultraviolet light inspection, looks for the cracks on the surface of the track. And this, the ultrasonic waves inspection, looks for the cracks beneath the surface of the track. Now, I would like to ask you a question. Can we detect problems before they happen? The answer is yes. As all these problems like loose components, cracks on the track, they all share a common root cause, that is vibration. We do train health monitoring and vibration monitoring every year, but as you can see from this picture, it's a very tedious job. We need to run wires all along the train like a spider web and connect it to the data logger, amplifier, power supply, and the laptop. That's the reason why we invented the V-sensor, to make it small like a credit card-sized device. Therefore, we can install it on the train, under the train, or anywhere else. What's inside the V-sensor? It's a spring in micrometer scale. When the spring vibrates, it will vibrate with the train. And we connect it to the microprocessor to get the vibration data to do data calculation. What is V-sensor? It's portable with battery power, a small electronic board, which includes the microprocessor, micro SD card, and the micromechanical sensor. It's totally unmanned, as it can detect train location without GPS. Its three-axis vibration monitoring includes the large one-condition sensor and the tiny sensor. Its high-speed system, capable of the 1,000 meters per second on microprocessor on the real-time operating system. So this is the next generation V-sensor over here. It's ultra-low power consumption with the sleep mode and Apple iWatch CPU. It can record timestamp by the real-time clock and the backup battery. It can be mounted with a magnet, which is very convenient. And it's IP65 waterproof sealed, and it's very small, like a credit card size. It's Bluetooth 4.1 wireless connectivity. The most importantly, it does fully automatic calculations. Here is a software that we developed all by ourselves. What you need to do is very simple. It just import data, select the train stations, which one you want to analyze, and you click a button here. The report will be generated automatically. Here are some applications. This is the point machines monitoring on the railway track. We install the sensor on the train and let it run through the train line. It can record all the condition of the point machine on this train line. And here is the data result. You can see from here, the vibration is very high. So we asked the maintenance team to replace the rail nose here. After the maintenance, the vibration drops to a very low level, as you can see. It proves that the vibration monitoring is very effective. Besides, we can use it for overhead line equipment monitoring. The left-hand side is the original design, and the other side is the modified design. Our sensor helps us to design a completely new component and structure to reduce vibration. Also, we can use it for track defects recognition. Using frequency analysis, on this side, you can see for the 0 to 5 Hz frequency range, there is no obvious vibration. However, for the station in this area, for the same frequency range, there is obvious vibration. And it is the corrugation defect. Using frequency analysis, we can identify what type of defect it is on the track. Previously, we have seen how we can use the sensor for track or overhead line monitoring. Now, we can even use it to design new train components. This is a train mirror. And there was breakage here on that point. So we installed the V sensor on the train mirror to do vibration monitoring. We import the data to the simulator, and you can see that there is a red location here. It means it's a high-stress area, and it corresponds to the welder location, and it is the weakest location of this component. Therefore, we weld a plate on top of this component. Before, it was red in color. Now it becomes blue. It means it's safe now. And that's the real-life reinforcement. And it never had any problems ever since. Besides railway industry, we can also install it for airfield ground lighting in the airport. We installed a sensor inside the lighting container and found that over 18 lighting are with excessive vibration. These lights are safety critical items. Our sensor monitoring have potentially saved lives. For tangible benefits, our sensor is much cheaper than the other one in the current market. For intangible benefits, technology drives change. It can change boring job into good and professional job, builds our expertise in condition monitoring, forces continuous improvement, and boosts employee satisfaction. For testing, we have achieved a lot of certifications. And this video is showing the mass production process. Do you still remember the Singapore train? Imagine if we can install the sensor all over the train to do big data analysis. We can prevent problems before they happen. I will end this presentation with a quote. The whole ground can be against me, but if I know it's right, I will do it.
I said, welcome to the new age,
Thanks
to
so
the
much
new
for your
age,
listening.
to the new age. I said, welcome to the new age, to the new age.
So next is a Q&A part.
Thank you so much for this presentation. I'm from the aerospace industry. We have aerospace health monitoring system already in place. It's interesting to see that it's been used to monitor potential problems on the train. Yeah. So maybe a little bit more. Your examples are all evolving around trains, right?
Yeah.
So could you share with us a little bit where are the places we should mount this to monitor potential defects on the train so that we can do preventive maintenance before the problems come. Where are the location that you will advise the train operator to place this on the train to prevent the problems?
Sure.
All right.
Of course, the closer to the point, which is the most accurate. But if we, like for the point machine monitoring, there are lots of point machines on one railway track, just like this point 1, point 2, and to the end points. But in this, lots of money costs us lots of cost and maintenance manpower. So we will choose, like for the train, we will install it on the train to likely run through the train line. Then you can record all the position of the point machine, or the vibration monitoring situation. So after the data analysis, we will find out which one is with the highest peak. That means it has an excessive vibration here. Then we will drill down to this point, install 1 or 2 more sensors here for in-depth analysis. But for the other application, like in the airport, we will use one batch of sensor for the lightings here to measure the points here. Then for the second batch, we use the same V sensor to get the vibration data, then to compare their vibration status to see which one with the highest peak. So that's the method to save cost and manpower. Yeah. And the accuracy is about positive or negative 3%. It's quite good, yeah.
So currently, I can see that you do manual analysis about the vibration.
Yeah.
Is there any plan that you will build in some alarm system whereby it will trigger the person rather than you analyze it manually?
Sure, that's a very good question. That's our future development. In here, we already embedded the Bluetooth 4.1 wireless connectivity. So in the future, we will install the Bluetooth and 4G module on the train to receive the data from this Bluetooth module. Then we will send back the processed data to the condition monitoring center in my company. So it can generate alarm, and the data we can use it to do predictive maintenance.
Hi, again, it might be a silly question, but how often do you have to replace the batteries?
Yeah, that is again a good question. Here is the lithium battery. The reason why we don't use the rechargeable battery is due to the safety reason. We need to install the sensor to somewhere with very high temperature and high vibration. If there's rechargeable battery, it may cause explosion. However, for this, the lithium battery is cheap. We can replace it anytime. Then we can secure our safety in our company or in the other applications.
Just as an add-on question, I think, yes, you can replace it fairly cheaply, but how about the environmental impact of constant replacing this? I assume you're not talking about one sensor. You could be talking about 10, 20, or 50, I don't know. And on a daily basis, you're talking about 100 batteries. At a year, you're talking about 3 over 1,000 batteries.
Yeah, we have considered it before. So we make an improvement here. This sensor will have a lifetime for a week, which is 7 days. So we need not to change the battery for a week to catch the processed data instead of the raw data. So it saves us lots of battery here to let it last for 1 week.
How much time would we have? 20 seconds. Right, that's all right. A quick one, 15 seconds. Morgan?
Okay, what would be the cost of applying these sensors onto a train to track it over a week?
The overall cost? So each sensor costs about, just go back, oh, okay. The slide is not here. It's about 100 Singapore dollar. So for the whole project, to count it in Hong Kong dollar, it's about 40,000. It's not expensive. To have the software modification and also mounted by my company's manpower force. And to do the data analysis is all, actually it's free as it is done by ourselves, but not the contractor help us to do it. So it's very cheap, yeah. Thank you.
All right, thank you very much.
Thank you for the question.
So the next up will be Lee.